All right, well, it's 9 a.m. Pacific time. I want to thank everybody for coming to this webinar. We've been doing these Q&A sessions for a few weeks now, or actually the last couple months. Every Wednesday or every other Wednesday at 9 a.m. we do an hour of Q&A session. Just to let you know that our everything is currently stored on our shared drive. It's a Google Drive. This is a link for it. It's http://tiny.c/roles shared drive. If you want a link for this, I can send you a link for it. Just go ahead and send me an email at steve@surrett.com. I'll also send you a link to our YouTube site. My contact information, my name is Steve Higgins. I'm the Technical Services Manager for Rolls Battery. I've been in the solar business for a little over 25 years. I've been with Rolls since 2012, so I'll be finishing up my 8th year here in August. My contact information, I have a direct number, 902-597-4020. It's at the plant, and then if you want to call me on my mobile, you can, or you can call me on my toll-free number. When there is no COVID-19 situation out there, I do travel quite a bit, a couple hundred days a year. So sometimes the best way to get a hold of me is to send me an email at steve@surrett.com. A couple of housekeeping items. We're going to try to keep this to 60 minutes. You should have a panel that looks like this on the screen. If you're having trouble with your computer audio, you can call the number listed. It is not this number. Don't use this number. I just took a screenshot of an old one to show people this, but do not use this number. It's not going to be good. Use the number that's on your actual screen, okay? Internet information, and you might get some better audio. But what you want to do is we've got everybody's microphones muted. The first one of these, we tried to do microphones for everybody, but unfortunately it just didn't work out right. So what we're doing is you should have a questions, you should have a questions panel. The questions panel is right here, okay? If you go ahead and type in your question, I will go ahead and answer that question verbally so everybody can hear it. I'll read the question and then I'll answer the question verbally. And then we'll, if you have any follow-up questions, I will keep an eye on it for follow-up questions. Looks like you got a few people. So if you go ahead and click on the questions arrow, the little arrow right here, open that up, and you can type in your question and send your information. All right, so at this point, I'm going to do a little bit of filler information until we get some questions, until I see some questions pop up. I don't see any questions in there, but we're going to talk a little about battery maintenance. It's very important that you do your battery maintenance and you take care of your batteries. Without battery maintenance, you're not going to get a warranty on your battery, no matter who manufactured your batteries or the quality of the batteries that were manufactured. The number one priority for battery maintenance should be safety. When performing battery maintenance on batteries, it can be very hazardous. I have been in rooms where batteries have exploded due to hydrogen ignitions. I have been in rooms where the hydrogen sulfide gas was so bad, within about 5 minutes of being in the room, your vision blurs, you get headaches. It's not any fun. So you need to make sure you have the right personal protective equipment to make sure that you're safe and that you're taking care of business in the battery bank. The number one thing is that all charging should be shut down. Open up all the doors and windows in the room, make sure it's well ventilated. And the reason for that is the hydrogen sulfide gases that are coming out of the batteries when they're charging. If somebody walks in that room with a lit cigarette, or they light a cigarette in the room, or you drop a spanner and it arcs across the battery posts, you get a nice big spark and that ignites the hydrogen gas in the air. You could blow the tops off one or more of the batteries. You could spray yourself with acid. It's going to cause you problems. It's not fun, and it's definitely not entertaining when you're in a room when a battery blows up. Some of the tools that you should have. First thing you should have is you must have a coworker. If you don't have a coworker, you're just inviting disaster. You've got to have a coworker. If you don't have again, as I said, if you don't have a coworker, if you make a mistake, you're going to have no one to call 911 to help you out, or no one to help you out if there ever is a problem. 12 volt, 24 volt battery banks. You can, believe it or not, you can get shocked with a 24 volt or a 48 volt battery bank. I have been shocked by a 48 volt battery bank in the past, and I can tell you this, it's no fun. So you're going to want to have someone on site to help you out. Couple of the PPE, personal protective equipment you should have. Gloves, you should have safety glasses, you should have some sort of mask. You know, the gloves to protect your hands from the electrolyte. The electrolyte you're dealing with is only a 38%, 62 or 68% water, 32% mix of sulfuric acid. So if you pour the electrolyte, or you get electrolyte on your hand or your arm, it's going to cause some irritation, some redness. It's not going to melt your skin off, but it's enough irritation and enough redness that you don't want to deal with on a constant basis. So if you're going to do a lot of work with a lot of electrolyte, I'm going to use, you know, elbow length, maybe even armpit length gloves. If I'm just checking specific gravities, I'm just going to wear a powderless black nitrile or a nitrile style glove. Safety glasses. Safety glasses are an absolute must. You have to have them. You walk into a battery room, you should always have some sort of chemical resistant glass on. If you're pouring a lot of electrolyte or dealing with a lot of electrolyte, like for example, when I do a battery teardown, I will wear a full face shield to protect my eyes, just in case I get a splash of electrolyte into my eyes. Again, a mask to protect yourself if you're working with a live battery bank that's charging and you're not doing any maintenance, you're just doing voltage checks. It's a good idea to have some sort of carbon mask or some sort of filtering mask to filter out those gases. Again, if you're going to be in the room for a period of time, you know, and you're checking specific gravities, or you're checking voltages and the batteries are charging, that mask is important to make sure you don't get headaches or blurred vision. I see a question, why? Question mark. What is that for? Can you elaborate a bit more on your question, please? I'm going to go ahead and, oh, wait a second. Here we go. All right. I do have one question, so I'm going to go ahead and pause. Battery storage. Are batteries okay to store on racking, shelving, or need to be stored on the ground, and why? Okay, that makes sense. Sorry about that. If you're storing batteries, a lot of times they're stored on pallets. You can store them on racking or shelving if you want. You can store them on concrete. You can put them anywhere you want, really. The batteries today are made of polycarbonate plastics. A lot of times we hear the wives' tale where you don't put batteries on concrete. You don't put batteries on concrete in the 1920s and 30s and the 40s because the batteries were made of glass, or they were made of, the battery cases were made of glass, or the battery cases were made of rubber. Glass and rubber are very conductive to cold. And so what would happen is that cold would go into the battery and sap the battery capacity. So the batteries of today, especially Rolls batteries, they are made of a polycarbonate plastic. They're okay to store on racking and shelving, and they're okay to be stored on the ground. No problem with that. Racking or shelving, they should be on a pallet so you can easily move them rather than having to get up and lift the batteries. I'm not a big fan of the multiple tiered racking out there, especially if you put a flooded lead acid battery, because often you're elevating the battery high enough that you can't get to the vent wells to do your maintenance. So that becomes a problem. Hopefully that answered your question. I'm going to go back to what I was talking about until we get any more questions. Okay. All right. So back to maintenance real quick. And so as we were talking about maintenance, um, again, wearing a mask is definitely something you want to do, especially if you're working with batteries. I often go into battery rooms while they're charging. Spend 15, 20, 30 minutes in the battery room, spot checking specific gravities or voltages. I typically don't do connection work with them, with those battery banks, because the last thing I want to do is drop my spanner and cause a spark and ignite the hydrogen gas. So you must have a refractometer or a hydrometer. And you should have a decent quality one. I am a big fan of the refractometers. The reason I am is that I can take my refractometer and I can measure 24 cells in about 7 minutes. Basically what I do is I have the lens cleaning cloth. I have the dipper. I dip it into the battery. I have a tape recorder lit. I have on my phone set to record. I dip the pipette into the battery, take a couple drops, put on the slide, look through it, take the cleaner, clean it off, and move to the next one. And I can get 24 cells done in about 6 to 8 minutes, depending on how many interruptions I get and if I'm trying to teach somebody something. So not a big fan of the glass turkey-based hydrometers. The one hydrometer I would suggest that you avoid. A lot of places you can go into a Napa or a Canadian Tire or an automotive store or hardware store and buy these plastic boxed see-through hydrometers called Easy Red hydrometers. Oftentimes, even out of the box, brand spanking new, they will read about 15 to 20 points high. So they'll give you a false indication or reading. So that's definitely a problem. You want to make sure you will look out for that, and you don't fall for that. So distilled water, you've got to have some sort of distilled water, some sort of water to be able to top off the batteries. Okay. More and more I am finding cases where distilled water has been compromised. I found my first one about 1.5 years ago. I was up in Victoria doing a training class, and I bought some distilled water from Save On Foods, and I was showing people how to measure the total dissolved solid content of the water, and it tested at over 900 parts per million. And so one of the tools that you might want to look into when you're dealing with distilled water is you might want to look into getting what's called a TDS meter. That's Tom Delta Sam meter. Okay. And so the TDS meter will allow you to check the particulates in the battery, or in the battery and the water that you're going to put in your battery. Just recently, there have been a couple of warranty claims that we did, and we pulled the batteries back for inspection, and we found that there's an immense amount of corrosion all throughout the battery. That corrosion causes excessive heat, and that causes you to burn the electrolyte or burn the active material off the plates, destroys the battery plates. So you definitely want to not use bad water. Of course, you having a wrench or a spanner, preferably if that wrench or spanner is dipped. Oops. What that means is that you've covered one end. So if you do make a mistake and you do drop the wrench or the spanner, you're not sparking and killing your battery bank. That's a big problem. You need to have a post cleaner or a battery post cleaner, wire brush. I prefer a file or a rasp. And the reason I do is that the file or a rasp allows me to, what the heck is going on? That file or that rasp allow me to clean, it allows me to go through and clean both the battery terminal and the battery lug. And so when I'm going through and doing my monthly maintenance, and I've got to clean the terminals, I'm going to take the terminals off. Of course, the system's already shut down. Take the battery lug off, rasp the battery lug, rasp the terminal, make sure I got some nice clean copper, a nice clean lead. I make my connection, and then over the top of that connection, I will take a dielectric grease or petroleum jelly and add that to the and put that over the top of the connection once the connection's made. You do not want to put the dielectric grease before the connection. If you do that, you're going to be causing all kinds of problems with your conductivity, and you may have some losses there. Okay. Next thing on the tools, torque wrench. You've got to have a torque wrench. It blows my mind how many guys connect batteries and that they don't even torque the batteries down. How do you know you've even come anywhere close to the torque setting of the battery connection if you're not doing a torque wrench? If you're not using a torque wrench. So a couple other things to have: baking soda. You need to have some baking soda on the system to make sure you clean. Make sure you can clean the connections. A little bit of baking soda goes a long way. So if I'm cleaning the tops of the batteries, I'm going to take 1 part baking soda and 2 parts water. So I'm going to take a ½ cup of baking soda and a cup of water, mix it in a small bowl, let everything dissolve, let the baking soda dissolve. Then I'm going to take a shop towel, like those blue rag shop towels you can get at the automotive store, dip that in there, and then wipe down the tops of the batteries. And then I'm going to follow it with distilled water, and I'm going to clean off the tops of the batteries. You do that because you want to keep your battery tops clean. The other reason you do that is if you're doing maintenance work for your customers or end users, you want to be able to tell if they're overfilling their batteries. And so if you come back and it looks like there's a liquid on the top of the batteries, that tells you that the client's been overfilling the batteries. For safety's sake, you're going to want to have an eye wash kit. Okay. I carry 2 eye wash kits with me everywhere I go, but especially when I know I'm doing any kind of battery maintenance. If I'm going out to a site to go do an eval or commissioning or maintenance on a site, I'm going to bring a couple of eye wash kits just in case there is a mistake. Just in case for some reason I didn't wear my glasses, didn't protect myself, I can at least flush my eyes out if there's a problem. The first tool I take out of my kit is I put the eye wash kit to where I can get to it quickly, to where I can get to that kit quickly if I need to use it. Don't leave it in your toolkit and then have to find it when you're partially blind. Okay. Seth has asked me, have I ever had to use those eye wash kits? In 25 years, I started working on batteries in 1995. In 25 years, I've had a couple of close calls, but I have never had to flush my eyes because I have always worn some sort of protective eyewear when I've been when I've been in a battery room. And every time I've had a battery blow up on me twice in 25 years. One time I was just outside the room when it blew up. One time I was about 8 feet away when it blew up and sprayed electrolyte all over the place. I had my my glasses on and I was safe, so it wasn't a big deal. When you're doing maintenance, make sure you remove your jewelry. Okay, the batteries don't care how pretty you look. They don't care about your necklaces. They don't care about your wedding rings. They don't care about your watches. Take that stuff off, because I can't tell you how many people have lost fingers and wedding rings because they've reached into an electrical panel, or they reached into a panel and it shorted across the hot and neutral, and your ring connected to the hot and neutral, and something shorted, and you've had all kinds of problems. There's a Facebook forum called Electrical Hall of Shame, and it's got some pretty interesting videos on it from time to time of people losing fingers in their life because they made a mistake because they touched something they shouldn't be touching. No open flames, period. This is a must. Okay. If you're working with me in a battery bank and you walk into the battery room with a lit cigarette or you light up a cigarette, I will probably smack you up the backside of the head. I will probably, what they call it, I will probably give a slap you. Because it's not a good thing to be doing, especially if the battery is charging. You could ignite the hydrogen and that will blow the tops off the batteries and cause all kinds of problems. A polyester cotton mix clothing is the best, but is common. So I typically, most of us all wear jeans and a t-shirt. I've got probably in the last, I've probably replaced 60 or 70 pairs of jeans over the last 25 years because I've leaned across a battery bank and I wasn't wearing an acid resistant apron. I've got shirts that I've got holes in them from doing battery maintenance. Anybody that does any kind of battery maintenance for any kind of period of time has lots of holes in their clothes. So it's a good idea to have an acid resistant apron. I wear an apron typically when I'm doing a lot of wet work, when I'm doing a lot of work with electrolyte. Like for example, if I'm cutting apart a battery. But I typically wear, jeans and a microfiber shirt, and that helps keep me from getting a lot of nasty destroyed clothes. So take care of yourself on there, and make sure if you don't know what to do, make sure you ask questions. Right. All right, so on flooded lead acid batteries. Oops. Oh, what the heck happened there? Sorry about that. A little bit of technical difficulties here. So flooded lead acid batteries, every 30 to 90 days, you should be doing every one of these things. And so it's to tell someone in specifically what their maintenance schedule is going to be battery dependent, and it's going to be customer dependent. Okay. So you want to be careful you want to be cautious with when someone asks you specifically what they need to do, because it's hard to judge. Every customer is different. You could sell the same system to 100 customers, and there's going to be 50, 60, 70 different set points, and there's going to be probably 20 or 30 different performance indicators. And so every system, if you treat every system the exact same way, you're going to end up backing yourself into a corner and causing yourself problems. On a flooded lead acid battery bank that's established, every 30 to 90 days, measure and records loaded and resting and loaded voltages. Check your and record your electrolyte levels. Record your specific gravities. Adjust your charging settings based upon your specific gravity measurements. Blows my mind how many people do their battery maintenance and they sit there and they watch their specific gravities over the winter fall and fall and fall and fall, and they never adjust their settings. They never become more aggressive on their settings to correct low or falling off specific gravities. Or in the reverse, customers also seem to have issues when the specific gravities go high. You don't want your specific gravities to be above 1.280. And so when they get above 1.280, 1.290, 1300, 1310, 1320, you are overcharging those batteries. And so you need to back off your charge times. And so, if you start seeing high specific gravities, you need to adjust your charge times down. There's a lot of people that don't look at this and they don't make changes, and they just sit there and let the batteries cook, and the batteries will eventually die. So you need to, so you check your specific gravities. If they're too high, then you take a half hour of your absorption time and you spot check them again in 2 weeks. If they're too low, say they're 15, 20 points low, you add about a half hour to your specific gravity. If they're 20 or 30 points low, then you add an hour, maybe an hour and a half to the specific, or even add a little bit of voltage. I use voltage adjustments as a coarse adjustment, and absorption time adjustments or end damps as a fine adjustment. So if you're fine tuning the adjustments, you would use voltage, voltage of course, and time as a fine adjustment. Okay. Check the ambient temperatures of the battery rooms. Check the cell temperatures of the batteries. Batteries do not like to be above 25 degrees Celsius. Batteries that spend extensive amount of times at 30, 35, 40 degrees Celsius, you will see reduction in life. You need to educate your customers. You need to educate your clients on that. When you have a battery that sits at just 35 degrees C, if you installed a battery bank and the battery bank's at 35 degrees Celsius for 12 months of the year, 365 days a year, 24 hours a day, 7 days a week, you're going to see a 50% reduction in the overall life cycle of those batteries, which means if they're a set of S6L16HCs, they've got roughly around 1,300 cycles of cycle life. Now you're down to 700 cycles if you install it in that case. Now, most systems aren't going to see those temperatures 24 hours a day, 7 days a week. And so ballpark, like for example, this is what I tell folks in Puerto Rico and the Caribbean when I do training down there. When you install the batteries in, say, San Juan, Puerto Rico, and they're typically installed in an outside area lean-to where the batteries will see average ambient temperatures of 30 degrees Celsius, and they'll peak up to 40 to 45 about 4 to 6 months of the year. That customer is going to lose about 30% of their overall cycle life on those batteries. So it's important to make sure that the batteries are installed in a cool, dry environment with plenty of ventilation to make sure that the batteries, that you ventilate that hydrogen gas. So the next one is cell integrity, especially for folks in Canada. It's a good idea, especially in their spring maintenance, to check the cell integrity. And the reason for that is that when batteries sit at a low state of charge over a 4 or 5 or 6 month period, or the customer forgets to turn off the inverter when they leave the cottage. If the customer forgets to turn the inverter off when they leave the cottage and the inverter's been running all winter and then drawn the batteries down to almost nothing and the batteries are frozen, you definitely want to inspect your cell integrity before you start adding water to those batteries, because if you just add more water to it, you're just going to make more of a mess. Okay, so, and that's another pet peeve of mine, I guess. There should be some space. There should be 1 to 3 inches of space around the batteries, 6 to 20 millimeters, or 10 to 20 millimeters around every, or centimeter or millimeters around every one of the batteries. That gives you airflow, but it also gives the ability to visually inspect the batteries and make sure they're okay. If you butt them all together in a container where they're tightly fitted in the container, you can't tell if there's been a problem with the batteries. You can't inspect the cell integrity to make sure that the cells are okay, that they haven't frozen over the winter. So, all right. Inspect for corrosion, inspect and clean the corrosion for your racks and cabinets. Corrosion on battery terminals and batteries in general is caused by 3 things. 1, overfilling of the batteries. 2, improper ventilation or poor connections. That's what causes corrosion on battery banks. It just doesn't happen naturally. If you have proper ventilation, connections are tight, and your customer is not overfilling your batteries, you shouldn't get any corrosion on your batteries. I'll talk a little bit about that later when we get to it. Check the battery monitor equipment to verify its operation. If you have an Outback FlexNet DC, if you have a Schneider BMK or a Magnum BMK, or if you're using the Victron equipment and they have a battery monitor kit, you need to compare the 100% stated charges versus what they think 100% is. I can't tell you how many systems I've gone to where they've had a BMK or a battery monitor kit of some sort, and the battery reports that it's 100% state of charge, but your specific gravities, they're measuring 1220, 1230. They're 60, 70% state of charge. That is typically settings or teaching the battery monitor what actual full charge is. So, and then last but not least, top off the distilled water as necessary. Again, it's a good idea to go through and check your distilled water and making sure that you have good quality distilled water. Nowadays, after the couple of places I found that I've gotten bad distilled water at, you want to definitely check that. Excuse me, with a TDS meter, because if you're not, you could end up with problems where your batteries are sulfate to the point, or your batteries corrode to the point where they start getting hot and they start cooking off the plate material. All right, so all right. So every 180 days, you're going to want to test ventilation. You want to make sure that ventilation is working. Again, check for high resistance connections. Don't just go and tug on the cable. If the cable's already been welded tight, you know, and you've got a poor connection there, it's been welded. You've got a poor connection there, and you can't see it. And so I use a FLIR camera or an infrared camera to take a look at the connections under load to see what the temperatures are. What you want to do is you want to put a wrench on it. So you put your spanner on there, you back it off a half turn, and then you retorque your connections. If the connection snaps or is very stiff, or you can't loosen it easily, that means you've had loose connections in the past, and it's a good idea to replace the hardware. Check your cabling for broken or frayed cables. Make sure that your crimps are still good on your cables. Make sure animals haven't chewed on the insulation and exposed the cables to mishaps. You know, recheck certified output. Make sure your charge controllers are actually outputting the voltage. So connect to your PV array, start charging, measure the output of the charge controller, make sure it's getting to the bulk absorption voltage, and then measure the battery and make sure those voltages correspond. If you measure the output of your charge controller and it's outputting at 59.6 and 59.2 volts is getting to the battery, you may need to recalibrate your charge controller or raise your voltage to get the right voltage to the batteries, because you've got an extreme voltage loss in your cables, or you've got a bad cable. So you want to definitely take a look at that. And again, inspect cells for cracks and evidence of leakage, and then ensure your ground connections are still tight, because bad grounds lead to bad things. On absorbed glass matter gel batteries, typically absorbed glass matter gel batteries, they say there's no maintenance to them. That's marketing mumbo jumbo. You want to do these things with, oops. Yep, well, I got the typo on this, so I apologize. So on absorbed glass matter gel batteries, you're going to want to measure and record resting and loaded voltages. Basically do a load test on them. I would do them, but I would do it every 180 days. You could do it every 360 days. But you're going to need to look into that to make sure that you're charging. If you install a set of batteries, come back in 6 months and you find the batteries are all low in capacity, then that tells you that you're not charging the batteries correctly. Ignore this one. Just charging settings based upon your specific gravity readings. That should be a just charge setting based upon your loaded rested voltage readings. If you've got a loaded voltage and they're all the batteries are testing low, that means you're undercharging and you're damaging the batteries. If you do the test and you find one battery, say there's 6-volt batteries, and 7 of the batteries are 6.2 volts or 6 volts under load, and you got one battery that's 5.4 volts under load, you have one battery that's probably in the process of failing. And so typically, if it's just one cell, it's probably a issue with the battery. If it's multiple cells or multiple batteries, it's probably due to an extensive amount of time at a low charging voltages, and the entire battery bank, you need to start looking at possibly replacing it. Again, ambient temperatures. Absorbed glass mat batteries and gel batteries are even more sensitive to temperature than flooded batteries, because they have no way to vent. There's a vent in the battery, but when it vents out hydrogen and oxygen, which means it's venting out electrolyte, and that's going to cause you problems. Again, inspect for corrosion, clean that, and then check your battery mount equipment to verify your operation. And then lastly, On absorbed glass matter gel batteries, the same thing. If you do have active ventilation, which is great, test it, make sure it works. Make sure you don't have anything blocking passive ventilation. All batteries, no matter what type of battery they are, especially lead-based batteries, you should have some sort of ventilation. By code, both NEC for the US and CSA code, you must have active ventilation for flooded lead acid batteries. For AGM batteries, louvers and vents are typically good enough, but you need to make sure you have positive and negative flow. Again, check for your high resistive connections, broken or frayed cables. A lot of this is the repeats, but this is just your typical maintenance of what you do to a battery bank. Battery watering, okay? Water is not created equal. Here are the different types of watering that I've had that people have talked to me about. Distilled water, bottled drinking water, deionized water, reverse osmosis water, rainwater, water collected from an air conditioner. A lot of people will set a bucket under the air conditioner, collect that water and use it to put in their batteries. Not a good thing. Lake water, river water, not a good thing either, okay? Distilled water. Yes, you can use distilled water. Do I trust all the distilled water sources? Not a chance. Not after the last couple of years of seeing bottles of distilled water in the 700, 800, 900 parts per million of total dissolved solids testing. It's not good. So nowadays I test all my water sources to make sure that I'm using the correct water and that it's been properly taken care of. You are never to use bottled drinking water, ever. That's a big no. Deionized water. Yes, you can use it. Your pH has to be as close to 7 as possible. And again, you have to test it to make sure that you're less than 5 parts per million of total dissolved solids. If you put bad water in your batteries, it's just going to cause corrosion of the batteries. Reverse osmosis water, you can use it, but again, you need to test it. You need to make sure it's less than 5 parts per million. We actually had a customer once in cottage country in Ontario. Their customers were making maple syrup with tree sap, of course. They were taking the maple tree sap and they were making maple syrup. And when they run that through the distiller, they get cast off water. They were taking that water and putting that water in their batteries. And that water tested anywhere from 700 to 1400 parts per million of total dissolved solids. They effectively killed their batteries in less than 2 years. Rainwater, that's a big no. Water collected from the air conditioner, it's a big no. Lake water or river water, again, big no's. If your customers are doing this, they're using bad water, it's going to cause a problem. We just got a teardown done this morning we replaced 3 batteries out of a system in BC recently. We tore down the batteries, brought the batteries back to the plant, tore them down, and the batteries are full of corrosion. The customer has been using bad water this whole time. And so we've already replaced the 3 batteries. The next thing I got to do is I have to write a letter and notify the customer that the battery bank is no longer covered under warranty because they've been using bad water. So this is what corrosion looks like. This is pretty common, unfortunately. We see we've got the corrosion on the batteries here. So we've got the corrosion on the battery here. This corrosion here is basically cleanable. You've got to disconnect this connection completely, and you've got to, I would almost probably take a Dremel to this thing, clean off this lug, get some nice clean metal, clean this lug, clean the battery lug. You've got to replace the RTV silicon here because if this can get into the battery and cause and eat the lead posts, lead strapping underneath this. Basically what's happening here with this particular client is that the distributor came to the plant, gave Jamie this picture. Jamie sent me this picture, and of course I told him that he's overfilling his batteries. Or they don't have enough ventilation or a few other things. And of course the distributor said, no, there's no way the customer is overfilling their battery. About a month later, we went to the site. About an hour before we came out to the site, the distributor called the customer and said, hey, we're on our way. We'll be there in about an hour. We got out to the site. We took the terminals. We took the hydro. They had the old hydro caps. Took the hydro caps off all the cells. They had 24 cells in this battery bank. Every one of the batteries was filled to the brim. Okay. When I mean filled to the brim is the water level should be no closer to the bottom of the tube that extends into the battery than 6 to 13 millimeters. Okay. If it's closer than that, what will happen is that when the batteries are under charge, it'll force the water out, and the water will force out onto the top of the battery. The best way to tell this is if customer's done this is take your voltmeter, put your voltmeter on the negative of the battery, the negative on the negative, take the positive, set it to voltage, like 20 volts, 40 volt scale, and put it on the top of the battery on the plastic. If you get voltage there, that means your customers overfilled those batteries at some point. And so there's a couple problems with overfilling the battery. The first problem with overfilling the battery is you get this nasty corrosion. The second problem with overfilling a battery is you're forcing the electrolyte out of the battery. That electrolyte is made up of a delicate balance of sulfuric acid and water, 68% water, 32% sulfuric acid. If you're pushing the water, the electrolyte out of the battery, what happens is now you're lowering, and then you add more distilled water. Now you're lowering the amount of sulfur that's in that battery, and you're lowering the overall max specific gravities that you can get it from that battery. So that's a definite problem that you're going to want to be careful of, is that your water levels should be no closer than 6 to 13 millimeters from the bottom of that battery. If they're closer, you're going to have all kinds of problems. You're going to have all kinds of issues with overfilling and corrosion problems. Underfilling. This is what a underfilled battery plate looks like. Okay, so this is a system that, of course, we replaced the batteries under warranty. The customer swore that, matter of fact, the customer went as far as to say, I'm a police officer. I'm the most honest guy on earth. And so we swapped out a couple batteries for them, and then we got the batteries back. And when we did the teardown, this is what we saw. It looks, if you see right here, it looks like a flood line. And so what you see on the plate, this is the envelope material, and this is the actual plate. And you see on this plate, you see the little specks on the top of this plate, all that additional corrosion there. That is oxidation from the battery being exposed to air. Okay, this is what a 10-year-old plate looks like. Or this is actually another one. You see this line right here? That's also an overfilling situation or underfilling situation. So the customers ran the batteries dry. Is that covered under warranty? No, it's not covered under warranty. Again, that was another letter that was written to the customer, letting them know what happened with these pictures and the evidence, and let them know that unfortunately they were no longer covered by a warranty. Here's that battery that was that I mentioned earlier that the customer was using. What they were doing is they were using the cast-off water from the reverse ionization process of making their maple syrup, and they were putting that water into the battery. And so this is the corrosion that we saw on the plates. As you see, that corrosion is all throughout the entire cell, the entire plate of the battery. This plate is what a negative plate should look like after about 10-15 years of use. You can see a little bit, there's a little bit of sulfation. You got sulfation here, there's a little bit of sulfation, a little bit of sulfation. You've got some plate degradation. You can see some gaps between the grid. You know, that's typical wear and tear. So, did I taste? Oh, I just got a question. So I got a question, so I'll just finish up with this slide real quick. Yeah, and so this is what a plate should look like after 10-15 years worth of use. So definitely you can tell 2 years, this is 2 years, and this was a 12-year test on this battery. So we cycled it for about 12 years every day we simulated like 3,000 cycles in this cell, and this is what it looked like. So I guess we got another question. I'm not sure if I should name who it is. It seems kind of like a smart ass question. Did you taste that battery? No, I didn't taste the battery. So sorry about that. I try to avoid tasting sulfuric acid. It's not a good thing. All right, so we have been going for about 35, 40 minutes. Are there any further questions? I don't see any other questions. What I'll do is I'm gonna quickly skim through. Actually, I'm gonna talk about a couple. I'm gonna skim through this, and then I'm gonna talk about some other situations. Absorption times. Absorption times are incredibly important. Matter of fact, it's the most important setting of anything. You can get your absorption times right, or you can get your voltages right, but if your absorption time, if you leave it at the default setting, you're going to get it flat out wrong. Okay. For matter of fact, there's one inverter manufacturer that actually advises you incorrectly how long your absorption time should be. So you have to be cautious out there about what your absorption time should be. You need to trust the battery manufacturer of how to program your absorption times. This is the finishing of the charging cycle. The absorption time is from 80% stated charge to 100% stated charge, okay? So it's the last finishing charge. If you always get that battery, if it's a lead-based battery and you're getting that battery to, say, 90% stated charge every day, you're eventually going to lose that top end 10% of that capacity. If you don't finish that charge at least once, twice a week, you're never going to get that top end capacity. And so it's going to cause all kinds of problems with the battery, and it's going to affect your overall capacity of the battery bank. Okay. On solar controllers, this is free energy. Okay. So you can go a little crazy on charging settings. Most customers don't have enough solar to properly charge the battery bank in the first place. So wind and hydro systems, typically you have to use a dump load controller. So on wind and hydro, I will typically set my targets a little lower than my solar, because my solar regulators are much smarter than most of your wind controllers and your hydro controllers that are out there. Okay, so for example, bulk absorption voltages for Rolls batteries is the same for Series 4000, Series 4500, and Series 5000 product. Okay, keep that in mind. Generally, it's 2.45 to 2.5 volts per cell. So a 48 volt system, it's going to be between 58.8 and 60 volts. On the solar, I'm going to set that at that high end. I'm going to set that at 59.6 to 60 volts. Or if it's a 24 volt system, 29.8 to 30 volts. If it's a 12 volt system, 14.6 to 14.7 volts, or 14.7 or 14.8 to 15 volts. I want to maximize how much solar power I'm charging the batteries, because it's free energy. If you're not maximizing it, you're wasting it. On a full-time off-grid system, you need to have enough solar to get those batteries fully charged with a reasonable amount of sun. Okay, to do so, you need 10 to 20% of the battery bank C20 rate. So if you're putting in a 1,000 amp hour battery bank, you need a charge source that's between 100 and 200 amps of current. Okay, if this is a cottage, say it's a temporary use cottage where the customer is coming out there on the weekends, or they go out there for 3 or 4 days, and then they're gone for 2 or 3 weeks or 2 or 3 months. You can go as low as 5%. So if you have a 1,000 amp hour battery bank, you can put in enough solar to do the 50, 60 amps of current. The problem is that while they're there on the site, if they're using the loads and the solar is so small, they're going to have to run a generator to make up for those losses. Because if they go out there and they live at the site for 2 or 3 weeks, by the second or third day, they're going to be struggling for power. So you need to make sure you educate that client that while they're there, the power that they use needs to be replenished, and to do that, they have to run the generator, every X amount of days. So, let's say it's 2 strings of S6 460 L16s. I'm sorry. S6 L16 HCs, which are basically the S550s. That would be an 890 amp hour battery. If you say you put a 4 kilowatt array on that, your absorption times would be in the 5-6 hour range, which means actually they'd be about 5 to 6 hours. And so what that means, it's going to take 2 full days of sun to get the batteries back to a full state of charge just from an 80% state of charge. And so if you set your absorption times too low, you're going to have problems. If you set your voltages too low, you're going to have issues. Okay. And so if you've got that 4 kilowatt of solar, and they're using say 10-15% a day, by day 3, day 4, they're going to have to start their generator to help the solar. And typically what I tell them is start your generator on day 3 in the morning, 7 o'clock in the morning, and let it run until the solar panels until the sun hits the solar panels. At the end of the day, when you're done charging, the solar panels charging, go and spot check, or at the end of the day when nothing's charging, sun's gone down, go out there and spot check the specific gravities. If they're not 1.265 to 1.275, then run the generator until they get there and then shut the generator off. Okay. That way that customer gets those batteries to a full 100% charge every 2 or 3 or 4 days. And then 2, 3, 4 years down the road, they're not dealing with having to equalize the daylights out of the battery bank to recover it. Okay. Wind and hydro, again, bulk and absorption voltage are generally the same. I will typically set them a little bit lower on wind and hydro than solar systems, again, because the wind and hydro controllers just aren't the same. They aren't the same as they would be for a solar system. So simple, 12 340 watt modules is 4,080 watts. 4,080 watts divided by 48 volts, it equals 85 amps of current. So if the world was perfect, connections were all perfect, solar panels were all perfect, charge controllers are perfect, perfect sun, perfect temperature, that panel would be able to deliver 85 amps, probably more, especially if the temperatures were cooler. Okay. Now realistically, that 80 amp controller is really going to be doing between 50 and 70 amps of current. Okay, realistically. And so you have to plan for that. You have to adjust for that and understand that, because if you don't, what's going to happen is if you set it for 80 amps, you do 0.42 multiplied by 890, 0.42 multiplied by 890 divided by 80 amps. That's an absorption time of 4.6 or 4.7 hours. Okay. But if you're really only doing 60 amps, 0.42 multiplied by 890 divided by 60 amps of current, that's 6.23 hours. So if you're only absorbing, if your charge controller goes into float after 4 hours and 50 minutes, when it should hold it for 6 hours and 30 minutes, what's going to happen to your battery bank? What will happen is you will slowly see, if you're looking at the specific gravities, that your specific gravities slowly tail off. You know, this week they're 1260, 1270. Next week they're 1240, 1250. The week after that they're 1220, 1210. The week after that they're 1180. Next thing you know, 2 or 3 months later, or what happens is 2 or 3 years later, the customer calls me or they call us, or someone goes out to the site and looks at it, and they look at the settings and they go, well, your absorption timers were all wrong. And so you want to be very cautious of that. And so if you're not, what's going to happen is that you're going to have all kinds of problems with getting those batteries to a full 100% state of charge. And so you need to make sure that you are setting this absorption time right. So on this system, your absorption settings really are going to be between 5.3 hours and 7.48 hours. Okay, and so what do you do? And so what I'm going to do is I'm going to go somewhere in between. So I'm going to set my absorption time at about 6.5 hours to start. Sorry about my chicken scratch. So I'm going to set my absorption time at about 6.5 hours to start. Okay, question, do you get 6.5 hours of sun, or do you get 8.5, 9 hours of sun every day to do a full bulk absorption time. You don't. And so you have to be cautious with that. You have to be careful with that. If you have an absorption time of 6.5 hours, you're never going to complete a full charge in one day. Okay, so this solar array, this 4,000 watt solar array is under designed. It's not designed. It's probably okay for a cottage. It's not okay for a full-time house. If you put this in a full-time house, your customer is going to come back to you in 3, 6, 10 months and complain because he's running his generator too much. So, I'm going to start at 6.5 hours, and then I'm going to watch the specific gravity. So I'm going to give the customer 2 or 3 or 4 weeks. I'm going to call them up and I'm going to say, hey, Joe, what are your specific gravities at the end of the day? And so I'm going to have them email me the specific gravities at the end of the day. And if they're low, then I'm going to advise him to run his generator in the morning at least 2 or 3 or 4 times a week, depending on how low they are. That way, if you run your generator in the morning before the sun hits the panels, you're maximizing how much power the generator is producing to the batteries. And then you're using the free energy to finish the overall charge. Okay. All right, so we are at about 56 minutes. I'm going to hit on the inverters real quick, and then what I'm going to do is I'm going to finish up. Hopefully we haven't had any further questions. I appreciate everybody listening, listening to me ramble on. Hopefully this is all making sense. All right, so on the inverters, I typically will set the inverters a little bit lower than my charge controllers. And the reason for that is if you have an automatic generator start, if you're using automatic generator start, then you want to prioritize how much the solar is actually running. And so if I'm going to set my solar controller to charge at 60 volts, I'm going to set my inverter to charge at 59.6. Okay, and the reason for that is, again, is I want to maximize what my solar is actually producing. Okay, so, I'm going to, okay, so yeah, so I'm going to set that voltage a little low. And then of course, the same goes with the inverters. What's going on here? The same thing goes with the inverters. If I have an inverter that's capable of 80 amps of current, it's not going to do 80 amps of current in real world. A couple of years ago, I was at a site with a Magnum inverter, and it was a 24 volt Magnum inverter that was capable of 105 amps of current. It said it was charging at 90 amps of current, but only 75 amps of current were getting to the battery. So that's why it's incredibly important for you to actually put a current meter on the output and check the actual current that you're delivering to the batteries. Because if you're not, then what's happening is that you're guessing and you're not getting your settings right. And that's why it's important, especially for lead acid batteries, to go through and verify against the specific gravity to make sure you are getting to a full 100% state of charge. Okay. I want to thank everybody for listening. I appreciate it. If you have any comments or questions, if you want to tell me what I did wrong, feel free to send me an email with, did I have another question? Yeah, okay, I didn't have one. If I did something wrong or you have a question, be sure to send me an email. I'd be more than happy to answer your questions for you. Again, here is my email address, steve@surrett.com. Like everybody, I'm currently stuck at home, so I'm also answering phone calls. So if you want to give me a call, you can dial the 902 number or the 800 number. My extension is 4020, so feel free to give me a call. I appreciate everybody listening and watching. You guys have a good day and stay safe. Wash your hands. Take it easy.